Hey guys, and welcome back. It's hard to believe, but this will be your final Envision math lesson for our school year. It's really been crazy to think about, but this is it, guys. So if we were actually in school, you would have been done a whole lot earlier than this. Probably would have been done at about the end of March. Maybe early May, right after spring break. But yeah, we would have been done well before now with Envision. So, but anyway, it's still joyful that we get to cross this end point in the year. So, hooray! Congratulations, you guys made it. You just got this one last Envision lesson and assignment to get through. We'll still have other reviews and challenges and activities for you to complete over the next couple weeks, and then that'll be it, guys. So we are winding down, and you have about 2.5 weeks left of school, and then you'll be off to enjoy your time a bit more. Okay. Two items to note before we begin. First is that just a reminder that your 8th grade Khan Academy, which you need to have 30% done, is due by May 21st, which is a Wednesday, and the second to last day before the fourth quarter is officially over and the school year is over. So I'm giving you that time. Then when you get to that 30%, just let me know, and I will gladly record that for you. Okay, so that's the first item of note. Make sure you keep working on that. The second item that I have for you is about your summer work project. Okay, or just summer work that you'll be that Mrs. Clausing, who is the honors algebra teacher, has given you guys. I will have more details on this summer work assignment on Thursday. Okay, so in the update that I give you on Thursday, video update, I will detail the summer work assignment for you guys. Okay, I'm not going to go into that now, but I will answer all questions and give great detail and information about the assignment on Thursday. I'm just making you aware. For those of you taking honors algebra next year in 7th grade, will have to do a summer assignment for Mrs. Clausing. Okay, so just a note on that. And then without further ado, let's jump right on into Mr. Sorrell's 6th grade trivia for today. So today's trivia has to deal with pizza. Okay. And in 6th grade, I just, as a child, I loved pizza. So, I don't eat too much of it now. But I just remember eating pizza all the time. Really. It just seemed like friends, sleepovers, parties. It seemed like pizza at least once a week, multiple times a week. I don't know. That's what it seemed like looking back on it. Whether it was frozen pizza, ordering out from a pizzeria, just so many ways that we consumed pizza. Anyway, I'd like you guys to try to guess at what was the pizza that I liked. So type of pizza, like cheese or anchovies or pepperoni or trying to think of some of the other ones. Hawaiian pizza, the Mexican style pizza, blanking on margarita pizza, and so on and so forth. So there's a bunch of different types of pizza, styles of pizza. So I want you guys to guess what type of pizza I liked in 6th grade. And bonus points because I'm handing out bonus points for this, not extra credit points. It's not going to impact your grade or anything. I just bonus points. If you can guess what my favorite pizza place was. Okay. I will give you a hint on that. There's maybe like 2 locations in Dayton, but a lot of locations in Cincinnati of this pizza place. So that's a hint there. And I want to know from you guys, what is your favorite type of pizza? If you like pizza, and maybe you can share what your favorite pizza place is. If you don't like pizza, or you don't have a favorite pizza place, you can give me your all-time favorite food, if that's what it is. Okay? So I want you guys to go ahead and answer that question now. So my favorite pizza when I was in 6th grade was pepperoni pizza, particularly from La Rosa's, which is a Cincinnati-based company. I loved it. Got it for a lot of occasions. Like I said, a lot of different times. A close second, I will say, is Donato's, which I know is another location that isn't quite popular up in Dayton, but it is down in Cincinnati. So those were definitely 2 places, and that was the pizza that I enjoyed. So moving on, today we are moving into 11.8, which is dealing with angles, lines, and transversals, which we'll get into today. It's a lot of important concepts, a lot of vocabulary that we'll be going over today. So it's going to be handy for you, if you don't already, to get a piece of paper and a pencil to write down some of these vocab terms and to draw some of these pictures that I'll be putting up. And at any point, feel free, you can pause this video to write down the vocab words and definitions and pictorials that you'll need. Okay? That's the content that we're going to cover today, is getting an understanding of what transversals are and the type of angles and lines that are associated with those. Okay? So we have Sarah, who looks very happy down here, by the way, in her green gloves and yellow work apron. Okay? She's building a handrail for a ramp. Looks like it might already be built. According to the design plan, the post must be parallel. We want to know how Sarah can determine the angles formed by the post and the ramp are related. So how the angles and the post of the ramp are related. So here's the post. As you can see, we have them parallel, and here we have the handrail that's going down with the same slope. Remember that terminology with slope. It's decreasing or increasing at the same rate. So here are those parallel lines that are representing the post. In this case, there are 5 parallel lines, or 5 parallel posts. This handrail that we have going across the post all the way down, representing that slope, is what we're going to call a transversal. Okay? And I'll have the definition and the word on the next slide, so don't worry about that right now. But in essence, a transversal is a line, it's a straight line continuing on like the same slope, same pattern, is a straight line that's going to cut through at least 2 other lines. At some point on the transversal, it cuts through 2 other lines. Typically, these 2 other lines or multiple lines are parallel, but they don't have to be. Okay? In this case, so we do have at least 2. We in fact have 5 parallel lines or posts, but notice we actually only need 2 of them. Okay? We're going to break down, kind of just focusing in on these 2 posts, what that looks like. Okay? So looking at 2 parallel posts here, we have line R, and line S that continue on in both directions forever and ever and ever. Line T is going to represent the transversal. Now, we technically in this diagram, we should have the transversal be the rail, but they illustrated it differently and cut it down through here. It's the same. This line is representing the rail. Just keep that in mind. Okay. So these little arrows on the lines on R and S are indicating that they are parallel to each other. Okay, if we had multiple sets of parallel lines, so like this would be one arrow, one arrow. If you had another set, then there would be 2 arrows on that. And another set would be 3, and so on and so forth. Okay. As I said before, this line T is representing the transversal. Here's this vocab word, transversal, and the definition with it. So the transversal is that line that's going to intersect 2 or more lines at different points. Okay. As we said before, most likely they're going to be parallel. I'm actually going to draw a little arrow here. It's probably something you may want to add to your definition. They don't have to be parallel, but you will often see them as parallel lines. Okay? And it cuts through into the 2 points of it. With this transversal that cuts through the parallel lines, you can form 8 angles here. Okay? And so taking this diagram, this picture, we're actually going to draw it into this now. So we have line R and line S with the transversal of line T right through both of those parallel lines. And here are the 8 angles we have. They are labeled 1, 2, 3, 4, 5, 6, 7, 8. They won't always be in this exact position, so don't get comfortable thinking that these number angles will always be there. They won't. Okay, so 1, 2, 3, 4, and then you can see the other 4 on the other side. Okay, very important that you understand that concept, that there's going to be 8 angles. Now, when you get obviously more parallel lines, more angles that you have to deal with, and when you get to transversals that are parallel, cutting through other parallel lines, then you got a ton more angles. So just keep that in mind. 2 parallel lines, 1 transversal gets you 8 angles. Now, the first type, as you could say, type of angles that we're going to refer to here with this particular diagram is what we call corresponding angles. Now, corresponding, if you're just thinking about the word corresponding, it's referring to angles that are in a line with each other, okay? Or in this case, what we are saying as congruent, okay? And it's not just any type of angle that's congruent, we would say corresponding. There's another part of it. So corresponding angles are congruent, and they're also, we're going to add this to our definition, and I'm going to use a little symbol for and are on the same side. Give me a second. I'm going to pause it. On the same side of the transversal. Okay. Now this part of the definition might be a little confusing right now, but hopefully as I walk through corresponding angles, you'll get a better understanding of it. Okay. So for example, what we mean on the same side of the transversal is that here's our transversal T. All of these angles above it, above the transversal, are on the same side of it. And all the angles below it are on the same side of it. Okay, 1 and 4 are on opposite sides of it. But 1, 2, 5, and 6 are on the same side of the transversal. Okay, so a corresponding angle would be an angle that's congruent to one another and on the same side. So let's take a look at angle 1. Well, we want to know what angle corresponds, or would be a corresponding angle with angle 1. Well, we can only look at the angles that are on the same side of the transversal. So that means we can only look at angle 2, angle 6, and angle 5. Okay. Well, it also has to have the same measurement, or be congruent with it. Well, when we look at congruency, it means that it's going to be the same measurement with that. Well, let's take a look at angle 2 first. Okay, could angle 2 be congruent with angle 1? Well, if you use some line property that you have before, you would realize that this is a straight line, and this is being cut by that straight line. Okay, a straight line will always have an angle of 180 degrees. I'm going to stop there, and you guys are going to go on to part 2 of